We'll do some revision of the number systems, and specifically how they all fit together. Now, you should be fairly familiar with the various number systems that we encounter in mathematics. Surely you have been working with the natural numbers or the real numbers somewhere before. Now, from the earliest times that people could speak and needed to count, they were using the natural numbers. This makes sense because they could see 3 rocks or 5 cows, natural things that they could see, but they had no comprehension for the number 0, as this simply meant nothing was there. They never thought of using the number 0 in their calculations, as even the advanced Roman numerical system indicates no use of 0, even when they got to 10. Today we use the decimal system. Now, the prefix deci means 10, which says that our number system is based on 10 numbers, which means all our counting is done using only 10 digits, 0 through to 9. And then for 10 we go 1 column to the left and start all over again, etc. Now let's just take a look at what that means. We have, for instance, in the units column, tens column and the hundreds column, we can start by putting zeros. And then from the units column we go 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. That's all the way up to the number 9. But now when we write 10, we say that up to now we've had zeros in the tens column. We don't write them on the left hand side, but they could have been there. So once we pass the point of 9 on the numbers, we then move 1 up from the numbers that we used. So the zeros now become 1. And then we start all over again. 0, and then 1, 1, 1, 2, 1, 3, all the way up to 1, 9. And then 20, obviously, that 1 becomes a 2, and we start all over again. 2, 0, 2, 1, 2, 2, all the way up to, for instance, 99. Once we get to 99, so far we've had zeros in the 100 column all the way up to this point. So now after 99, that 0 that we had in the hundreds column will now become the next number, the 1. And then we start all over again with 0, 0, and we're right back to where we were there. Then it becomes 0, 1, or alternatively 101, 102, and so forth. That's how we build numbers in the decimal system. Now the Romans had, for the numbers 1 to 15, the following use of the symbols 1 or I. Sometimes it's written as I, which indicates 1. V is for 5, X is for 10. So 1, 2 is 2 stripes, 3 is 3 stripes, 5 then is V, and 4 is 1V or IV because it's 1 before 5. 6, that side is 1 past 5. 7 is 2 past 5, 8 is 3 past 5, 9 is 1 before 10, 11 is 1 after 10, then 12, 13 will be 3 after 10, and 14 will be written as 15 like that, 10 and 5, but then 14 is 10 and 1 before 5. So it's 10 and 4 will give you 14. So that's how the Roman number system actually worked. So just take note of how these systems actually, or the numbers actually got written together. Now imagine how 134,567 would have looked in the Roman system. But they didn't have use for such large numbers. So for all practical purposes, their number system were sufficient for the time in which they lived. So the first number system that we will be looking at is the natural numbers, being natural things that you can see. And this is indicated by the symbol n, and this set consists of the numbers 1, 2, 3, all the way up to infinity. Infinity is like an upside down 8, where it indicates a number so large that we do not want to write it down. And since the biggest number we know of cannot be determined, we just indicate it by the use of the infinity symbol. Because remember, if I ask you to give me the biggest number that you can think of, all I have to do is to say but plus 1. Then I've got an even bigger number. And then you can say, okay, plus 1 and plus 1 plus 1. We can just add 1 to get a bigger number than anybody who went before. So it's very difficult to determine the biggest possible number, so we just indicate it by using the infinity symbol. If we now add the number 0 to our set so that the mathematics can start making sense. Having the number 0, we now talk about the counting numbers indicated by n with a little 0, or sometimes the whole numbers as well. Now for many years also, people never thought of using negative numbers in mathematics because the idea was just so foreign to them. Someone, however, found that he could not use mathematics to assist in his bookkeeping, as debt could not be calculated. They then started writing debt as negative numbers. In other words, if 3 people owed 10 Rand, 12 Rand and 15 Rand respectively, it could be written as minus 10 plus minus 12 plus minus 15, which then gives us minus 10, minus 12, minus 15, or minus 37. So the debt, the total debt, were added together as normal, 10 plus 12 plus 15, but it was written as negative numbers to indicate debt. So if the owner of the business then also does business somewhere else to the value of 45 Rand, he can calculate his cash situation by saying minus 37 plus 45 is equal to plus 8, where the plus then indicate cash in the bank. So the minus 37 is what he still owed, the 45 is what he actually has by virtue of doing business. So you can say the balance of the minus and the plus number is either a plus or a minus, indicating whether he still owes money or whether he has money in the bank. So the name we use for the number system, including all positive and negative numbers, is the integers, and it is indicated by the symbol Z. So to this point we have looked at all natural numbers, we've included 0 and we've included all the possible negative numbers, but we have not yet looked at any of the fractions. But before we do, however, it is important to discuss the various types of fractions that we can encounter. So first of all, we look at terminating fractions. These are the decimal equivalents of fractions such as, for instance, a half or 1 over 8. Recurring fractions, fractions of this type are decimals which repeat the same pattern forever, such as a third, which is 0.3333, etc., and it is indicated as 0.3 with a little dot on the recurring digit, where they just say that the 3 is being repeated. That's what the dot means. Now for the same measure, 0.256 with a dot on each digit would equal 0.256256 forever. And then we get the type of fraction which is none of the above. You'll notice that the first type of fraction, the terminating fraction, stops. After a certain number of digits, it stops. The recurring fraction never stops, but it repeats the same pattern. And then we get the type of fraction which is, for instance, the square root of a prime number, which doesn't do either. It doesn't stop, it just carries on forever, and it doesn't repeat any specific pattern either. Now the numbers 1 and 2, in other words the terminating fraction and the recurring fraction, are called rational numbers, and number 3, where it doesn't do either of that, will be called irrational numbers. Now remember, all integers, counting numbers and natural numbers are also rational, because if we take the number 3 for instance, 3 is a natural number, it's a whole number or a counting number, and it's an integer, but it can also be written as 3, 0. In other words, it stops. Or minus 5 can be written as minus 5, 0, or even minus 5, 0 forever. It still adheres to the property of either a terminating or a recurring fraction. And then we just need to look at the summary. All of these numbers can be included in the real number system. In other words, every number that exists and that you can think of will be a real number. There are 2 numbers, however, that can be present in mathematics, but they do not exist. First one would be a 0 below the line. You cannot divide by 0. The other one would be a minus under a square root sign. The square root of minus 4 cannot be determined. Remember, it is not equal to minus 2, because minus 2 times by minus 2, that's the purpose or the principle of a square root, is that you must multiply the answer with itself to get back to that number, and a minus times a minus is a plus. So minus 2 times by minus 2 is plus 4. We don't have a square root of minus 4. So these 2 types of numbers, 0 below the line or a root that cannot be determined, are called non-real or unreal numbers. So now we've done every possible number. Everything that exists, fractions, integers, the whole works, plus the two types of numbers that do not exist, and they are then called the non-real and the real number system. And then there's just a summary for you. The natural numbers, we've started 1, 2, 3, 4, etc. Then we added the 0, it became the counting numbers. Then we added all the negative numbers, it became the integers. After that, we looked at between every single integer we have three types of fractions. First two types would also be called rational numbers, and then this pink line indicates all the rational numbers. Natural numbers, counting numbers, integers, and two types of fractions that we've looked at are rational numbers. We still have the irrational numbers, square roots of, for instance, a prime number, and all the rational numbers and the irrational numbers are real numbers. And then we have the two types of non-real numbers.